Today I will solve graph coloring problem using graph coloring problem. Okay. First I will explain what is graph coloring problem. In graph coloring problem, a graph G is given and a positive integer m. Okay, and the graph G is given and a positive integer m. There are two types of problems. The first is M colorability decision problem. M colorability decision problem. Here the problem is whether a graph G can be colored, whether a graph G can be colored using M colors such that no two adjacent vertices are of same color. This problem is called M colorability decision problem, where a graph G is given and a positive integer m. Here m is the number of colors that can be numbered from 1 to m. Now the M colorability decision problem is a problem where just it has to find whether the given graph can be colored using M colors in such a way that no two adjacent vertices are of same color. For example, suppose the graph is one simple graph. G is A 1, 2, 3 and 4. Okay, so this is a simple graph and there are two colors, suppose three colors, m equal to 3. So first we can number the color as like 1, 2 and 3. Okay, so now suppose the first vertex, there are three choices for the first vertex to be colored. Either it can be colored by the first color or second color or third color. Suppose I colored this vertex with first color 1. Okay, so the second vertex is adjacent to 1. This cannot be colored with 1. 3 is also adjacent to 1. This cannot be colored with 1. And 4 is also adjacent to 1. So the 1 cannot be used for 2, 3, 4. So it means this graph cannot be colored using one color. So here there are m equal to 3. So now we can use the another color, say 2. Okay. So now after coloring the first vertex and the second vertex, for the third color, the third vertex cannot be colored with first color because this is adjacent to first vertex, and the third vertex cannot be colored with the color number 2 as the 2 is adjacent to 3. So I have to use the another color, say 3. Okay. Now the fourth vertex is adjacent to 1 and 3, but it is not adjacent to 2. So the fourth vertex can be colored with the color number 2. So for this problem, the solution vector is the color number is 1, 2, 3, 4, where this is the color number for the first vertex, this is the color number for the second vertex, this is for the color number for the third vertex and color number for the fourth vertex. So 1, 2, 3, 3, 2, not 4. 1, 2, 3, 2. These are the colored number. Okay. Now the same for the same number of color. Suppose I will change the graph like this. Suppose if we change the graph in this way. Suppose this is the graph. Okay. If we consider this graph and the same number of color, I am using the 3 color. So first vertex again, I am taking the first color. Now the second, third and fourth cannot be used with 1 because this is adjacent. So second vertex can be colored with the second color, and the third vertex can be colored with, it cannot be colored with 3. Okay, and as I am having only the 3 colors, 1, 2, 3, and all 3 colors have been used. Now there is a one vertex 4 which is adjacent to 1 as well as adjacent to 2 and adjacent to 3. So just no color is possible for the vertex 4. Hence this means for a given graph G, for this type of graph, this graph cannot be colored with 3 colors. This is M colorability decision problem, in which a graph is given and M number of colors are given, and now the problem is whether a given graph G, whether a given graph G can be colored with M colors such that no 2 adjacent vertices are of same color. So for this particular graph, this graph cannot be colored using 3 vertices, 3 colors. So for this graph, at least 4 colors are required. M equal to 4. Okay. If there is a if suppose the degree of a graph means maximum degree of any vertex in a graph. Here the degree of graph is 3. So if the degree of the graph is D, then a given graph can be colored with D plus 1 colors. Okay. So this is what M colorability decision problem. There is one more problem, that is M colorability optimization problem. What is this M colorability optimization problem? M colorability optimization problem. Okay. What is this problem? A graph G is given. A graph G is given. Okay. Now a graph G is given, and here in M colorability optimization problem is to find, the problem is to find minimum number or smallest number M, to find the smallest number M, so that to find the smallest number M, a graph, to find the smallest number of M, whether a graph G can, whether nodes or vertices of graph G can be colored so that no 2 adjacent vertices are of same color. Okay. Now, what is this M colorability optimization problem? A graph G is given, and our objective to find the smallest number M. So whether the nodes of the graph can be colored, so that can be colored using colors so that no two adjacent vertices are of same colors. Means just what is the smallest number m, smallest possible number of colors. Here in m colorability optimization problem, our objective is to find the smallest number of colors so that the graph can be colored using those number, and that number m, that is smallest number, that is smallest number of colors are called chromatic number. Chromatic number. Okay. So it is a difficult problem for any given graph to find the chromatic number. This M colorability optimization problem is more difficult as compared to M colorability decision problem. So here now today we solve M colorability decision problem using backtracking technique. We are not going to solve M colorability optimization problem. Just we are going to solve M colorability decision problem using backtracking technique. ठीक है, बस अभी इतना.